Hello guys, my name is Craig and welcome to Peri Solutions. Today we're going to look at differentiating a product. So to differentiate a product, we use the product rule. So say if we've got y is equal to uv, whereby both u and v are functions of x. For example, say y is equal to x squared times x to the power 4 minus 1. We see that this function of y is made up of two functions of x. We've got x squared and x to the power 4 minus 1. So in this type of situations, this is whereby we use the product rule to differentiate a product. So the product rule states that for a function y is equal to uv, dy by dx is equal to d by dx of uv, right, which is equal to u times dv by dx plus v times du by dx. So this is what we call the product rule. So now, say for example, if we've got a function y is equal to x squared times x to the power of 3. Right? Of course, we know we can multiply out and just differentiate the normal way. But in a situation whereby we want to show how to apply the product rule, this function is made up of two functions of x squared and x to the power of 3. So we let u be equal to x squared and then v be equal to x to the power of 3. Right? And then now we are going to differentiate. We're going to find the expression for du by dx. And now if we differentiate this u with respect to x, we get 2x. And then we're going to find the expression for dv by dx, which is going to be 3x squared. Right. And then now the next step is to substitute these u, v, du by dx and dv by dx into this. So we say dy by dx is equal to u, in this case our u is x squared, times dv by dx, which is 3x squared, plus plus v, which is x to the power of 3, times du by dx, which is 2x. So now we can further on simplify this to 3x to the power of 4. Is it? Yes. 3x to the power of 4 plus 2x to the power of 4, which simplifies to 5x to the power of 4. So now there we've applied the product rule to differentiate this function. And just to prove, if we are to multiply this simplifies to x to the power of 5. So now we know differentiating x to the power of 5, we drop the power of 5, multiply by x, then subtract 1 from the power of 5. So now this becomes great. So now I would like to look at these examples whereby we're going to differentiate using the product rule. Because now with these examples, you cannot further simplify these. Because this, for the first example, x to the power of 3 is a cubic function. And then now root of x minus 1, that's not a different function. So you can't necessarily combine the two. So now, let me erase this. So here we said dy by dx is equal to u times dv by dx plus v times du by dx. Right. So now for the first example, right, we want to find dy by dx. So in this case, we said this x to the power of 3, we make it u, And then, okay, let me write it. This, use blue. Okay, so x to the power of 3, we make it u. And then root of x minus 1, we make it v. Right. So now, u, dy by dx is equal to u, which is x to the power of 3, times dv by dx. So now we want to differentiate our v being equal to x minus 1 to the power of half. Right. dv by dx, we are dropping the power half, multiplying by this expression, x minus 1, then subtracting 1 from the power of half to get a minus half, then multiplying by the derivative of what's inside. Right. So there we've just differentiated by the chain rule. Then we're adding this plus v. V is x minus 1 raised to the power of half. Right, times du by dx. So differentiating that, dropping the power 3, multiplying by x, then subtracting 1 from the power of 3. Right. Then now we shall further on simplify this to 1 over 2 x to the power of 3 times x minus 1 raised to the power of minus half. Then plus 3x squared times x minus 1 raised to the power of half. So now this will be the answer. And of course, you can decide to put this in the denominator, then remove the half, the power of half by putting the square root sign. And then this is the numerator, you just remove the power of half and put the square root sign. So now this is what we get. And now let's quickly move on to the second example. Okay, so now for the second example, we want to apply the product rule, but we see it applies if we've got u times v. So now we've got a quotient, which means we have to take this denominator into the numerator. So we rewrite that as y is equal to 2x minus 7 squared times x to the power of minus half. Like that. And then now we can apply the product rule. So this being our u, so this is u, this quadratic function of the linear function 2x minus 7, and then the v would be just x to the power of minus half. So dy by dx would be equal to u, which is 2x minus 1 raised to the power of, 2x minus 7 squared times dv by dx, dropping the power half, multiplying by x, then subtracting 1 from the power of half, we get minus v over 2. Then plus v, which is x to the power of minus half, times du by dx. So now differentiating this, we're dropping the power 2, or let me say times 2, dropping the power 2, then 2x minus 7, subtracting 1 from the power of 2, we get a 1. Then multiplying by the derivative of what's inside the brackets, which is just 2. So now we can further on simplify this to see minus 1 over 2 x to the power of minus b over 2 times 2x minus 7 squared, then plus 2 times that 2, we get a 4, x to the power of minus 1 over 2, 2x minus 7. And of course, we know you can factor out. So here you can decide to factor out 2x minus 7. Right, so if you have to factor out 2x minus 7, 2x minus 7, right, you get minus 1 over 2x to the power of minus b over 2 times, let me put a square bracket there, times 2x minus 7, then plus 4x to the power of minus 1 over 2. Square bracket for that. And of course, this, if you want, you can go on further to simplify by putting this x to the power of minus 3 over 2 in the denominator, and as well x to the power of 1 over 2 in the denominator. So now this was for that example. Now let's look at the last example. Okay, so now for the last example, we want to differentiate this quadratic function of the function x plus 1 and that quadratic function of the function x minus 1. So now this is our u and then that's our v. So dy by dx being equal to u times dv by dx, we are saying that u is x plus 1 squared, then times the derivative of x minus 1 to the power of 4. So we are applying the chain rule here, whereby we're dropping the power of 4, multiplying by x minus 1, then subtracting 1 from the power of 4 to get a 3, then multiplying by the result of the derivative of what's inside these brackets, which is just 1. Then we're adding this plus v being x minus 1 raised to the power of 4 times du by dx. So we want to differentiate x plus 1 to the power of 2. So dropping the power 2, multiplying by x, by what's inside the brackets, and subtracting 1 from the power of 2, we get a 1. Then multiplying by the result of the derivative of x plus 1 is just times 1 as well. So we can leave it like this, right? Which we can now further on simplify to, let's see. So this simplifies to 4. So let me use green here. So this will simplify to 4 times x plus 1 squared. Then x minus 1 to the power of 3. Then plus 2 times x plus 1 times x minus 1 to the power of 4. But we see there are a lot of common factors there. So we see that 2 is a common factor in both expressions. And then as well, x plus 1 is a common factor. And then as well, x minus 1 to the power of 3 is also a common factor. So now this into that, 2 into 4 we get a 2. Then x plus 1 into x plus 1 squared, we get x plus 1. Then x to the power of minus 3 into x minus 1 to the power of 3 into x minus 1 to the power of 3, we get a 1. And then we now move on to this one. 2 into 2, that's 1. So we're saying plus. And then x plus 1 into x plus 1, that's also a 1. X to the power of x minus 1 to the power of 3 into x minus 1 to the power of 4, we simply get x minus 1. So now we further on simplify this too. We can even rewrite it as 2x plus 2, then x minus 1 to the power of 3. Then this will simplify to 2x plus 2 plus x minus 1, which we can go further to simplify to 2x plus 2 times x minus 1 to the power of 3, then 3x, because we're saying 2x plus x, we get a 3x, and then 2 minus 1, we get a 1. So 3x plus 1. Let me write this properly, like this. So this will be the final answer. 2x plus 2 times x minus 1 to the power of 3 times 3x plus 1. Okay, so this was applying the product rule when differentiating. Please, if you're new to my channel, don't forget to hit the subscribe button and the notification bell so that you don't miss out on any new content. Feel free to drop a like, leave a comment, and suggest any further topics. Thank you.